Okay, so we should be recording. Hopefully we're recording. We are multiplying and dividing rationals today. Some of this, again, should be fairly familiar. I know it looks like a garbled hot mess on there right this second. However, we will go through it a piece at a time, and some of this should be pretty familiar. Something like this expression over here, and I'm going to use white to annotate with, something about this expression over here that we're looking at, that shouldn't be too crazy. This is really just like multiplying a couple monomials and simplifying and canceling. Like, it's all stuff that you've done before. So this is sort of your simplest case scenario that we're looking at here. What we're going to do, of course, we always start easy. We'll move to more tricky. So rx squared over 9t cubed times 3t to the fourth times r. I have color-coded, laboriously color-coded, each of these terms. So notice that r's are blue, our t's are black, x's are red. Anything that's a constant is purple. So this is the same expression, just color-coded. Okay. So now we can cross cancel, because what would have happened if we were multiplying these is we'd have just had an expression that was like 3 rx squared t to the fourth. Well, we would have put the t first probably because alphabetical order, but you get the idea. It would have just turned into this expression anyway. So we don't need to take the step and multiply it out first. We can just cross cancel. Like we don't have to multiply it out first. We can just cross cancel. The more I see this, the less I'm liking this color, so I'm going to change it. Let's try that. Okay. So now I have my r's. See, we're looking at this section right here. Okay, we're just looking at this section. And I've canceled a lot of stuff out. My r's, they're out of there. Okay, there's an r on the top and an r on the bottom. Bye-bye. We have a 9 and a 3. Okay, well, that turns into 3/9, which would be 1/3. There's 1 3, there's 2 3s down here. That just turns into a 1. That one turns into a 3. Up here, I've got an x squared that goes with nothing else, so it stays x squared. Okay, and I have t to the third and t to the fourth, which these 3 t's are going to cancel 3 of these, leaving us with only 1 t left over. In green is what is left over. Anything that I've written in green is after the canceling massacre. This is all that's left. We have x squared, a 1, and a t, which means it's x squared t or tx squared, whichever you prefer. And on the bottom, all we've got is a 3. Look at that. Simplified expression. Okay? So now we're going to look over here at the bottom. Okay, we have quadratics. I love quadratics, so this makes me happy. Your mileage may vary. We've got a plus 4 on top, a squared on the bottom. I haven't done anything with a squared yet. I'm just leaving it a squared. That's okay. We're looking at this section now, okay? This is the exact same thing. I just put a plus 4 in parentheses. I know it looks like a 9. It's an a. Times a on our top, and I factored this. Here's my factoring work if you want to check me. Multiplies to -8, adds to 2, 4 and -2, no leading coefficients, so we can just write it as a plus 4 and a minus 2. Okay, so I have factored the bottom. Now we're on to this section. Okay, now we're on to this piece. And we can cross cancel. We have an a plus 4 on top and an a plus 4 on the bottom. Yay, bye-bye. A squared and a, cool. That a turns into a 1 because it cancels out one of these and you have a regular a on the bottom. So now all we have left is 1 on the top in our numerator, and in our denominator we have a times 1, which we don't care about, so a times a minus 2, a times a minus 2. Depending on your teacher and your class, they might let you keep it factored, or they might make you go ahead and multiply that and distribute that a through there, depending. It looks kind of crazy, but it's actually not as bad as you think, especially if they give you these nice, easy to factor expressions in your denominators. Factor it, cross cancel it, simplify. Okay. All right. Let's move on to some practice. Come on now. Oop, I'm going the wrong way. That's why. All right, find the product. So we've got 3x times 8x squared, 16x squared, 3. We don't have to multiply this out first. We don't have to do 16 times 3 and then simplify it. Why would we do that? We have a 3 on the bottom and a 3 on the top. This is all multiplied. There are no pluses and minuses. There's no other factoring that needs to be done. Get rid of those 3's. And then, of course, 8 and 16, that turns into a 1 and a 2, right? X squared and x squared, those cancel each other out. Oh my gosh, all we're left with is a 1 over 2. Not so bad. All right, moving on. Moving on. All right, now we're going to divide fractions. I'll just let you sit with this for a second. It's really not that bad. All right, the thing to remember about dividing fractions. I mean, you probably have been doing this since 5th grade, but everybody forgets it all the time. It's multiplying by the reciprocal. The definition of division is that you multiply by the reciprocal, okay? So A over B divided by C over D, it's the same exact thing as A over B times, flippy, the reciprocal, D over C, okay? It flips, times the reciprocal. That's why my students like to call it the refliprical, because you remember that you flip it. Okay, so this is still multiplication. We're still going to be doing multiplication. We just have to remember to flip our second term, to turn our second term into the reciprocal, multiplying by the reciprocal. Okay, so let's try these. All right, so 4 over 15n cubed divided by 12 over 25n. We have to rewrite this as 4 over 15n cubed times, we flip it, 25n over 12. And now we can cancel, okay? 4 and 12 turn into 1 and 3. 15 and 25, take out a 5, and you've got a 3 and a 5. Okay, and then we have an n cubed and an n up here, so this goes away, and this just becomes n squared. Okay, so that's still in play. All right, so on top we've got 1 times 5, which is 5 in our numerator. And in our denominator we've got 3n squared times 3, so it's 9n squared. Okay, well, let's keep looking over here. So 2x plus 6 over x squared divided by x plus 3. But how do we flip that? Remember, everything's over 1. You can always put it over 1 when we flip it. So we rewrite as 2x plus 6 over x squared times, we flip it, 1 over x plus 3. Now, at first glance, some of you may be saying, wait a minute, there's nothing to cancel here. Oh, really? Yes, there is. We have to factor this expression here. So rewriting it, we're going to rewrite this expression, okay? We're going to factor it. So now we factor out a 2, and we have x plus 3 on top. Would you look at that? Now, these cancel. And the x squared is just got to stay put. It's got to stay where it is. Nothing else to be done about that. Okay. In our numerator, we have a 2 times a 1, so we have a 2 in our numerator. In our denominator, we have an x squared. And we're done. This is the part of my class where I say, any questions? Because I'm just not used to talking to a blank screen. It's very weird. All right, let's try some different stuff. Fun times. Let's try rewriting a minus 2 over, let's factor this as we go, shall we? Let's factor this thing. This would factor into pulling out a 4, and you'd have a plus 1. Don't fall into the trap where you think that's a plus 0, all right? It's plus 1. A minus 2 over 4 times a plus 1 times, and we need to flip it, So now this is going to be our numerator, right? A plus 1 over a plus 5, and look at that. Something to cross cancel. Awesome. So now we have a plus 2 as our numerator, or a minus 2 rather. And our denominator, we have a 4 times a plus 5. And you can choose to distribute that in or not. That's as simple as it goes. I know there are people there going, but what about the negative 2 and the 4? Can we cancel? No, we cannot cancel. If it helps you to remember, put that in brackets so that you know that it's one binomial factor and you cannot chop it up. It's connected with a plus and minus sign. All right. Let's try some more stuff, shall we? In another video. I think we'll try more stuff in another video because next we're going to talk about dividing polynomials. It's actually really fun. So I will leave you with this screen, and next time we will divide much more complicated polynomials.